Hello. Today we're going to be talking about analyzing graphs, doing systems of equations, and doing a piecewise function review. So for number one, we want to be able to look at a graph and analyze a bunch of different pieces about it. So first of all, we see this classic U shape. That is a parabola, which makes this a quadratic function. Now the equation of a quadratic function is going to have a quantity squared here. Now in order to know what goes in there is going to be our vertex. So to move it right 1, it's going to be a -1, and down 4 moves it -4. Our a value would come from our stretch, but we can see we go over 1 and up 1, so we're not stretched at all. Our graph is going left and right for forever. Our graph goes down to -4 and up to positive infinity. For increasing, that's where we kind of look for where our graph is going up, and decreasing would be where our graph is going down. So as we're looking at that, you're only going to look at your x values, which means you have -1, nope, that's a +1 for your x value. And so it's on the right-hand side towards infinity is increasing, and from -infinity up until 1 is going to be decreasing. So increasing starts at 1 and goes to infinity, whereas decreasing starts -infinity to 1. Increasing and decreasing should always have parentheses. F of 0 is saying when x is 0, what is y? So it's saying 0 comma something, what is this? So your point down here is at 0 comma -3. My y value is -3. Whereas this next one is saying, I don't know what x is, but I know my y value is -4. So it's something comma -4. So we're going to look for which point has a y value down here of -4. And that happens when x is 1. So take a look at the next two and think about them first. F of -1 is when x is -1, y is 0, because it's at the point -1 comma 0. The next one is asking where is your y value -3, and it actually happens in 2 spots. It happens when x is 0 and when x is 2. So that's analyzing graphs of functions. Now what we're going to do is we are going to graph these different functions on the same graph grid. So for the first one, I'll graph this top quadratic in blue. It is left 1, down 5. And my a value is 2, which means I'm going to do 1, 3, and 5 times 2. So I go over 1 up 2, then over 1 up 6, and then over 1 and up 10. So I'm off the graph grid. I'm then going to graph my next one, my linear function here in pink. So this is a line, y equals mx plus b. So I'm going to go up to 1 and put a point, go up to right 1, and down to left 1. And I've graphed both of those on the same graph grid now. So go ahead and pause the video and try examples 3 and 4, and then come back here to see how they go. So for example 3, did you graph an absolute value that was right 3 up 5 with a slope of down 2 over, or down 5 over 2? Should look like a V shape. Check your points. It should look like this. And at the same time here, we can go ahead and graph this quadratic, right 3, down 4. And your 1, 3, and 5 pattern remains intact. For number 4, you have an exponential function, so we needed to make a table, -1, 0, and 1, 1 over b, 1, and b. And as we graph those ones, this is what your exponential function should look like. And then your linear function has a slope of -1, so that other one should look like this. So that's a quick review of all of the different types of functions that we talked about. Just put on the same graph grid, 2 of them together. Because now what we're going to do is we're going to take a look at these. We're going to write down what types of functions that we graphed, and then we're going to write down the system to the solution, the system of equations. So for this first one, we had the quadratic. That was the one in blue, and the linear in purple. This next one was absolute value and a quadratic. And number 4 here was exponential and linear. Now, for the part B down there, the solution is going to be where those graphs overlap. So for each of these, you want to figure out where they are touching, and those are going to be your solutions. So for the first one, it's -2, -3, and 1, 3. For the next one, you can see that they are intersecting at 1, 0 and 5, 0. And for the last one, they are intersecting at 0, 1. Those would be the solution to each of the following systems of equations. You're used to seeing it as 2 lines intersecting, but now we can see it with all different types of functions intersecting. Now what we're going to do is we're going to move on to piecewise functions. So number 5 is meant to be a review. This is something that we saw earlier with 2 linear functions. So what it's saying is it's saying graph this line, but you're going to take and you're going to say, okay, I don't want all of it. I only want like that part of it. And then it's going to say, okay, graph this line, but I don't want all of it. I just want part of it. And whatever your graph looks like after you kind of only take half of it, that's what your graph is going to look like overall. So let's go ahead and take a look at this then. So we are going to say, okay, first of all, let's figure out where we are dividing this up. And that's based off of that last part there. We are dividing this up when x is -2. Over here is everything less than -2. And on the right-hand side is everything bigger than -2. So we are going to graph this first line on this half. We are going to graph this line on this half, on the right side of that. So to graph this top one, what we're going to do is we're going to go to -2 on our y-intercept. We're going to go down 3 and right 2, and up 3 and left 2. And we're going to put points on both sides of that boundary line because we either want this first half or this half. And because we are on the yellow, we want the left half of that graph. And at our boundary, it should be an open circle because it is not or equal to. So I'm going to go ahead and make sure that this is nice and clear here, that this is an open circle right here. And I can then erase the right half of that graph. Now I'm going to graph this line. My y-intercept is 0, 0. My slope is 2. I'm going to go up 2, right 1. I'm going to graph some on both sides of my boundary, and then I'm going to figure out which half I want. And because I want the blue half, I want everything on the right side of this, I can erase the ones on the other half. And my boundary here is going to be a closed circle because it's or equal to. Now, based off of this graph, I can answer the next questions. Where is this graph increasing? Where is this graph decreasing? So over here on the left-hand side, I can see that it's going down, and then all of a sudden it starts going up after that. So my increasing is going to start here when x is -2 and go to the right for forever, whereas my decreasing started on the left half and stopped when x was -2. We can also evaluate the function for different x values. This is saying when x is -2, what is y? So we need to figure out that point -2 comma something. So we have 2 different points to look at. The one up here on the boundary is an open circle. The one down here is a closed circle. That means this is the one that we actually want to look at. So when x is -2, y is -4. So let's take that and try to graph a piecewise function with 3 parts. So first of all, I'm going to chunk up my graph at my boundary. A +1 and +5. So over here is everything smaller than or equal to 1. Everything here is in between 1 and 5. and then over here is everything greater than 5. So I'm going to graph my top equation on the very left, my middle equation in the middle section, and my bottom equation on the very right. So first I have to make sense of all of that, and then I have to make sure that I'm graphing the right functions. So I'm going to pretend now like these dividing lines aren't there, and I'm just going to graph this equation like normal. So left 1 and up 4. My a value is -2, so I'm going to go over 1, down 2, and then over 6, down 1, and then I'd be off. So I want this pink to be in that yellow section, so I really don't need to go to the right over here because that's not the section I want. I want the piece over on this half. And on the boundary here, I have to be careful. Oh, it is a solid circle because it's or equal to. So I just want to make sure I always go back and check that this part here is closed at 1. In between 1 and 5, I'm going to graph in blue y equals x plus 4. So that is a linear function. My y-intercept is at 4. Notice right here I am starting on my y-axis. I'm not starting on my boundary at 4. And my slope is 1. So I'm going up 1, right 1. And I want everything in the middle here. At 5 on the right-hand side, that is going to be closed. But on 1 on the left-hand side, that's going to be open circle. So I'm going to do an open circle on the left, a closed circle on the right, and connect everything in between. Finally, that last equation, the absolute value of x minus 6 means I'm moving my vertex right 6. My a value of 1 means I normally go up 1 over 1 continuously to get that V shape. But I only want the part that's in this green area on the right. So I'm going to connect this part of my absolute value, and I'm going to erase all of my other points that I didn't need. And at 5, this is going to be an open circle. So you can see it looks kind of like a Frankenstein type thing where you have different pieces of different functions all cut up and put on the same graph grid. That's why it's called piecewise functions. Now we can do our analyzing the graphs for this. So when x is -2, what is y? We can go -2 comma what? And on our graph grid, we can see here our y value is 2. When x is 5, what is y? Well, we have 2 options, but we want to go to the filled in one. So we would be up there at 9. And we want to know x when y is -4. So for this one, here's our y value being -4. We actually have 2 answers here, when x is -3 and when x is +1. So that's it for piecewise functions and systems of equations and analyzing graphs. Let me know whatever questions you have, and thank you for listening.